My name is Hod Greeley, and I am a fairly recent addition to the developer advocacy team here at Couchbase. Really happy to join. Today I want to talk about how to simplify your life as a mobile developer using Couchbase Mobile. And I'm really going to kind of take this from the perspective of sort of my own learning about this space. And so I hope to kind of bring you along and show you why I think Couchbase is a really great solution. So this is kind of the point of my normal talk. I'm going to actually deviate from my normal spiel a little bit. This is where I would kind of lay out the form of the talk and the sequence. But I'm not going to do that today. The reason I'm not going to do that today is because I really want people to focus on two key takeaways in this. So the first takeaway, here I'm showing Couchbase Lite is actually a standalone embedded on-device database that's fully featured and works as essentially a substitute for SQLite, only will show in some ways why I would encourage you to try it out. But it's also, so the first takeaway is that what I found in working with Couchbase is that I think it's actually not just easy to use, but it's actually easier to use than a lot of these sort of standard ways of handling data on mobile. What's cool beyond that, though, is that Couchbase Lite is actually part of this larger package called Couchbase Mobile, a larger stack. And that Couchbase Mobile overall actually will give you some capabilities that really give you what you want end-to-end, even for a sophisticated use in a mobile situation. And so those are the two key takeaways that I want to emphasize tonight, is that not only is it easier to use, but that when you need the rest of the stack, it's there and it won't leave you hanging. So, I'm sure lots of us have dealt with technologies that are, easy to get started with, but then trip you up later when you're trying to do something sophisticated. And I actually skipped over my questions because I've already asked people enough, but I'm gonna go back to them for a second just to get. So I usually like to get a feel for the crowd. So how many people here consider themselves like sort of an experienced mobile developer? Okay, so we have some people that are actually new to mobile in general. How many people have actually deployed something using, say, like SQLite for database? Slightly smaller group, but actually quite a few. And how many people are familiar with NoSQL and NoSQL databases? Okay, so we got kind of a mix going through here, so that's great. All right, so as I mentioned, I want to talk about how this is not just easy, but actually easier. And so let's go over kind of what are the typical things that are available. So this is, I will confess, is slightly Android-centric. That is more my background. I came from Samsung, what can I say? But basically the concepts that I'm going to present here, Couchbase Mobile is cross-platform. The concepts apply across iOS. They actually apply across other platforms. You can develop with the Java, in Java for Windows, all sorts of things. But I'm going to stick a little bit and focus more on Android to kind of for more illustrative purposes. So what are kind of your key options on Android? Well, you can of course do everything yourself, writing your own files. I mean, obviously, what's to stop you? You could write SQLite yourself if you wanted, and it's all files in the file system. But typically, if you're going to build it yourself, doing stuff on the file system is only going to be really feasible if the data is, if you're handling things like large blobs in a relatively simple way, like images or something like that, or a very small amount of data that you don't have to concern yourself with a lot of structure. System preferences, is designed, is kind of nicely integrated into the Android framework, and of course it was designed exactly for that, for helping ease setting up user preferences and things like that. But it's really only going to help you out for very small amounts of data. And actually, the way it's integrated into the system is something that you may not always want to be tied to. So then we get to kind of the heavy hitter for things where you have, more sophisticated use, where you have more sophisticated needs for structured data, and that's on Android is SQLite, and actually on iOS, I don't know if people know, but the core data framework that iOS uses, the underpinnings of that are actually SQLite. So on either of the main mobile platforms, you're actually tied to SQLite in effect. And then the last one, of course, is that you can do things. So these are all, you can simply classify them as kind of on-device solutions, but then there's, of course, the off-device possibility of going to the network. Now, for mobile developers, you'll know that going off-device is often problematic, especially if that's your only solution, requires you to be going over the network. Then when you've got spotty network issues and stuff like this, then you're in for trouble. And I'll actually kind of show a use case later on where it really emphasizes how important this can be. So for people in the crowd that are new to, especially new to kind of NoSQL, so I just want to briefly kind of give you some tips on things that you'll run into when people talk about the kinds of issues that you have in dealing with relational databases and SQLite in particular. So first of all, there's this thing about impedance mismatch. You hear this term used, and what people are really talking about is the idea. So I'm going to do a really quick history. So relational databases, you break up your data into tables. It's the general idea is that you're trying to make your tables structured really nicely so that you don't repeat data, and that actually ends up making it so the way you're representing your data in these tables is not at all the way you represent them in your code. And so that's where this idea of the mismatch comes from, is the way you want to manipulate things in your code is not real well suited to the way that it's going to be in these tables. SQLite in particular is, so there's this term about offline first, which is, people have gone from mobile first, now it's offline first, where you want people to not only have a good mobile experience, but you want them to have a good experience when they're not connected to a network. Well, the thing is that SQLite by itself is offline only, meaning that there is no standard solution, at least that we see in the field, for backing up your SQL, for keeping that, say, synchronized with some kind of back-end system. And then another issue that comes up that kind of relates actually to the earlier ones is this notion that when you do this table structure for a typical relational database, that actually locks you in to a rigid schema. I don't like to throw around database terms too much because, coming from a mobile background, it's like schema, schmema, whatever. But I'll go there a little bit. So key points about NoSQL and kind of in relationship to some of the things that I talked about. So NoSQL is actually something, so relational databases basically ruled the day from when Oracle produced the first commercial one in 1979 or something like that, through, I don't know, the 90s or so. But then, talking to people who live this every day, I'm pretty sure you understand that the challenges of modern technology and data have changed a lot from something where you had a central data store and a few people, operators that were dealing with it, to where maybe you have an app that's being used by millions of people. So that's just one example of some of the kind of changes that prompted this rise of this NoSQL. And NoSQL is really kind of this term that popped up. It's a little bit clumsy because it doesn't really give you a great idea of what it's talking about. So you can effectively think of it as things other than relational databases. Another nice attribute is that it's flexible. I'll get specifically into how it's flexible in terms of the schema, meaning that it's easy to make changes to the data that you're storing. But it's also flexible in a lot of other ways. And one of the key things is, here this notion of scaling out versus scaling up. So with a typical relational database, like I actually worked at a company before Samsung that had its own proprietary database, and when people wanted to get more performance, they bought bigger Sun boxes, and big Sun boxes are expensive, right? But that's basically largely your choice. Whereas with SQL databases, and we'll see a little bit why this is true, you can actually scale out, meaning instead of building up, one piece of hardware, you can actually buy a bunch of less expensive hardware and form clusters to do that. And what's cool about that is not only is it, good for your data center, it's less expensive to maintain that way, but it also means that, if you need to distribute this around the world, because again, your usage pattern has changed from being a bunch of people local to people using it globally, you can actually distribute that more easily and give, so that all applies to things like responsiveness and such. So there are several kinds of NoSQL database. I won't get into that. I'll talk about some details about Couchbase in particular that'll be relevant. So Couchbase falls into this subclass of NoSQL databases that we call document-oriented, and I'll explain what that means in more detail. The documents are represented in JSON. Who's familiar with JSON from web stuff? I imagine a lot of people have seen it. Yeah. So I'll kind of show you why it's nice that it's JSON. And again, that kind of ties back to this issue with the flexible schema in particular. So I'll take a quick pause because I need a drink. But also, this is a little bit of a break point. And so what I'm going to do next now is try and give you kind of a little bit of visual idea about what I mean by some of the things that I just talked about. So here we have an example. So what I have on, I'm really bad with hands, so I have to be careful. On the left side is sort of a visual idea of this might be sort of how I picture my data in my head. I've got my information here. This looks like it could be something that's like a user profile, or even maybe it's like a little mini resume kind of thing. And what you see on the other side here is how this would typically be broken up in a standard relational situation where you've taken this data and you split it up into these tables. And you can see, I think, pretty easily here, I can't just go to one table and pull this stuff and create the object that I want to manipulate in code. I have to basically do the reverse of this process of splitting it up. I have to reassemble it. And that goes to all actually the points that I made earlier about how, one, this illustrates that impedance mismatch that I talk about, and that the way you have to visualize and actually construct things and structure things for the database is very different than how you want to use it in your code. The fact that you have to pull these pieces together is part of why it's really hard to scale relational databases in the way you can NoSQL databases. And it's also related to why it tends to be less flexible. So the alternative, or what Couchbase does, is here where I'm showing the same data and I'm showing it in the JSON format. So for people that aren't familiar with the JSON format, JSON was really kind of designed to be super lightweight. I think you can kind of see, there's very little overhead in marking out the structure of this, but to also map very directly to some key structures that are pretty universal in code. So you have things like key value pairs for things, but then you also get into where you can actually have arrays, but not just simple arrays, but arrays of objects. So here under experience, we actually have kind of a sub-piece and multiple ones of them where you have both a role and a company field, and that's all done as one array internally in the JSON. So this data will be treated together typically as a single document. So you can see it's a very different kind of mode of approaching it than the relational system. So the short version of that is, with Couchbase Lite, you're effectively, this is what it's storing, and it's easy to manipulate. I just thought I'd reiterate that. Now to get into going back to why this is more flexible, here's a situation where we've got some simple information, and this is actually a really simple case. So what happens in a relational database when you want to add a new thing? So you've created your user thing, and suddenly you realize, oh wait, I want to add Twitter, a Twitter handle to it. So I actually have to go back and redefine my table for that. Relational databases don't actually deal well with things like empty table entries and stuff like this. So you are now in the land where even with a simple change like this, you actually have to start worrying about handling different versions of your database, like an upgrade path, or what happens if somehow somebody manages to load your app and they've got an old version of the thing and you want to keep using it without forcing them to upgrade, and it's going to crash if you don't handle it right. A bunch of different potential headaches. And when you get into more complicated situations, what tends to happen is that your database people start reusing columns and things rather than wanting to have to go through this process of updating. So things get kind of hackish. And you start to feel like this. So you can imagine the structure of this building was great to start. It was probably really, actually, kind of beautiful building at one point. But now over the years, it's starting to fall apart, and frankly, I find this a little scary. You could really make this a great Halloween, situation if you want. And that's I think the sense of some people have of diving into relational database systems that have been around for a little bit. Whereas if you want to do this, the equivalent thing in a document-oriented database, it's super straightforward because all you do is actually just start storing. You just add it to your document and go. An old version of the code would just not even realize that piece was there and wouldn't care. New version, if you're worried about a new version with an old database, you just pull in the document and check to see if that field's there or not. You don't blow up. You can still retrieve it nicely. And so you can even get by without even updating if you want. Or of course, it just makes it simpler to do your updates, typically. So now I've given you a little bit of a kind of mid-level sort of way to visualize some of what I'm talking about. So now I'm going to actually jump into some code. Everyone likes code, right? Yeah, okay. I don't know, I want to show up on one of these things where everyone's like, okay, you're about to code, I'm done, and I'm leaving. No, okay. So I almost feel bad doing this. I actually pulled this code from Google, from the Android documentation on using SQL. And what I want to illustrate here in particular is this is their example of what it takes to get started. And of course, these kinds of guys, right, they're showing you a simple example of what it takes to get started just to create the database. And in particular, I want to highlight here for people who aren't, people who are used to seeing SQL will spot it quickly, but people who aren't, is that what you're doing, so SQL is the query language that's like the de facto standard for relational databases. So in effect, it is its own language, right? And so you're having to cobble together instructions for this different language in the language that you're using in the language that you're using for your development, and they're not really a good fit for each other, right? Here I'm working in Java, and I have to piece together this table creation key. And what's actually missing that's kind of behind the scenes even further from this is that if I'm going to start building out my tables for the database, I better have sat down and kind of figured out the structure of them ahead of time, because otherwise I'm going to get myself into a mess. So even before you get to sit down and start writing your code, at least in theory, you probably should have spent some time planning it out a bunch. So, I build my SQL instruction here, and then I execute it down here. So all this code is the stuff that is necessary for kind of the standard way to get you going. And when I looked at this the first time, I felt like somebody asked me to sit down on this and, figure out how to fly it. It's like, okay, I know a lot about, I'm not a pilot. I hope to be one day. I know a reasonable amount. I'm actually a physicist by training, so I know how the wing stuff works. So I'd probably be dumb enough to actually try and figure this out, but it's probably not a good idea. Now, I'm actually doing myself a disservice here because what you're seeing looks like almost the same amount of code, right? So actually, these first 2 lines is what it takes to create the database. The rest of this code is actually already what it takes to initially commit some information into the database. So in less code than it took to just create my SQL database, I've actually created my Couchbase Lite database and put a document into it. And further, when I claimed earlier on that I said that Couchbase was not just easy, but easier than any of the standard ways, I haven't actually sat down to fully prove this out. But I think this is actually fewer lines of code to get going than if you just do the simplest thing using a file and mapping, using a library to map the JSON into the file. So it's actually as easy as or possibly easier than writing into a file yourself. So you've gone from, sort of SQLite level of complexity down to let's work with the file system level of complexity. Okay, so that was all great, but it was a simple piece. So let's break out and take a look at some code, and it's going to take a second to switch here probably. So to set this up, I wanted to give an example that was going to be kind of credible in a sense, because I don't know about you, but when I go and sit and watch talks, I'm a little kind of wary when somebody says, oh, look at how easy it is. It's like, well, and I'm going to show you an example. It's like, well, you got to cherry pick your example. So what I did here is actually went to, there's a tutorial site, it's one that I like, the Vogala one. People familiar with that? You've probably run into it if you do enough Android stuff. I'm sure it'll pop up in your searches at some point. Vogala, it's V-O-G, yeah. I believe it's actually the guy's name who originated, his last name is Vogel, and anyway. So I went and found their tutorial. It is a simple tutorial, introduction to SQLite. And so here's the app that you build. This is straight. Well, they don't actually have all the code, so I had to like, set up some manifest stuff and whatever myself. But it's just pulling from a few random strings and, adding it to a list, right? So this is super simple. Couple buttons here and a list view. And you get the idea of what it's doing. So I took that and I basically replicated it using Couchbase Lite. And so I want to show you kind of some of the different pieces here and compare and contrast. So, and sure enough, I'm going to spill things. I've got to flip the wrong thing. So the first thing in the Vogala demo tutorial, they ended up creating 4 classes to deal with this. Can people read? I don't know if you can read, you can see my tabs at the top or not, but there are 4 classes. One of them is pretty trivial. It's not like it's a huge deal. But what I found interesting is when I went to reproduce this is I ended up with 2 classes. And I didn't end up with 2 classes because I decided to stuff a bunch of code all into one place just to sort of make it, so I could stand up and say I only had to do 2 classes. I only ended up with 2 classes because that was really all that was necessary, and it was just easy to do it that way. What? Can you expand the font a little bit? Yeah, let me do that. bump this up. Let's try, how big do you want it, Nick? Should we try, let's see how 32 looks. Is that good? Okay, great. Okay, and just really quickly, I want to show that the structure of the code, you can actually see that so here's the main activity. They're structured similarly, both as list views. So I really was, trying to kind of adhere to their structure in doing this. So let's take a look at what these classes are and what they're doing. So to walk through, let's first start. So under Android, kind of the standard thing is that to help you manage what you're doing on the database, they have this class. It's a SQLite open helper, and typically you're going to build a subclass from this to do some things for you. So this is the code that's going to get into actually opening the database. And in fact, here again we see this nice string that you have to piece together for your SQL statement to create your database. And I feel, again, like it's a little bit telling that one of the methods that you actually need to write into this is your on upgrade. So that's foreshadowing your future in relational database land. And then in this case, all they do is actually just drop the table and basically start over. So you compare that, and this is actually really boring because it's so short. So here's my code to create the database. And just because it kind of makes it easy, if I essentially am checking here to see if it's the first time I've opened it, and I put in an empty list into the database the first time. But other than that, it's those same two lines that I showed you earlier, plus the boilerplate wrapper stuff. So does anyone think that's not as easy as the SQL part? So then let's compare some of the other typical pieces in here. So
you're cheating.
I'm cheating?
Because you're taking advantage of the fact that Couchbase doesn't have to deal with all that textual stuff of actually doing the connection string.
Right, and neither do you when you use it.
Yeah, exactly.
So
you can cheat too.
You can cheat too. So yeah, I am cheating. Okay. I'm sharing the cheating. And I'm going to try and stand here because the sun is really annoying. So I apologize for that. So let's zip through some of the things. So creating a comment here. The example. So they're following kind of standard practices. You create a contents value. You need to put your contents into that. Actually do the insertion into the database, and then in order to return something back to the list for the list view, they actually go through, do a query on the database, walk through it, and then pull out the comment again, and have to close it down and return that. So I think, again, that illustrates to me how, in some ways, dealing with database tables is really a mismatch with how you want to be programming. So to create, and I'll show this really quickly. So to create the comment here, I'm just passing in the comment string. I pull up all the comments list, again, add it, and call an update. The deletion is kind of similar. Here again, I have to build my SQL, a bit of a SQL string. And they're actually making use of this helper method down here to do some of the stuff of converting. So this piece where we convert this cursor to comment piece here is actually kind of hiding use of this helper function down here where you go through and build up this comment class to insert. So I also use the helper class. So you might, again, I'm waiting for everyone to be on the edge of their seats. It's like I'm going to catch them. So what did I bury in my helper class or helper method? So here's my update piece, which I use for both creation and deletion. And you see, so this is a pretty standard way of dealing with a document, sorry. I have my document already, so I got that when I opened my database. Couchbase works with this notion of revisions. It's how many people are used to using Git for version control? So yeah, you know how Git keeps kind of this idea of revisions, that you're not sort of having one set of version of your code, but you have the whole history of it. So Couchbase does something a little similar. It doesn't keep the whole history of documents, but it does, as you're updating things, it does keep a partial history of them. And it is a little bit similar to Git, and where you can actually have things like conflicting changes if you have documents that are being updated in two different sources at one time that are part of the same database. That's a more advanced topic, but you can actually deal with things like conflict resolution, and because you have this revision history. So the way I'm going to do updates to my database is I basically say I'm going to do a new revision. I then put my information. So the way that the JSON representation gets presented to you in code is through a map. And so I'm going to update my comment list by, instead of trying to revise it in place, excuse me. I'm actually just going to dump the whole array back into the map, and then you set those as the properties for the document, and then I go ahead and save it. So the nice thing here is that I'm dealing with all objects that are natural to my programming environment. These are things that I'm used to dealing with all the time: hash maps and arrays and things like this. So I think, you know, this helper function ends up being really easy to write and very straightforward approach to dealing with it. So those are kind of the key pieces of the code that I wanted to show. I don't know, do people want to walk through in more detail on stuff? Or?
Okay, well, while it's true that your code is more concise because of the fact you're using those using your library function, Couchbase, doesn't that complexity return back again once you start using the NoSQL query language?
So that's. Let me repeat the question. So for the audience, so the question was, does the simplicity here end up translating to more complexity later on in more sophisticated situations? And you refer specifically to the NoSQL query language that we have. So NoSQL right now is actually available on Couchbase Server. It's not. So the way you do querying in Couchbase Lite, I actually found, and again, going back to kind of my own history with this, when I was writing some things with Couchbase, I found it actually really easy to just deal directly with the hash maps and not even really use queries. But in case you want to do stuff, you can actually do really sophisticated stuff. It is a full-featured Couchbase Lite, SQLite. Couchbase Lite is a full-featured, on-device database. So you expect that it has, sophisticated ways of doing query. You query it using MapReduce technique. So if you want to do more sophisticated things, or you get into something where you need to handle data maybe a little bit larger scale than is feasible the way I'm approaching it here, you do bump up to that level of complexity. But again, I find that easier to once you kind of get your mind around what you're doing. I find that actually easier to code than SQL statements, because you're still really operating on things that are kind of more natural to the language that you're using. Because in MapReduce, for people who aren't familiar with MapReduce technology, really the map part, all it is in some sense, you can think of it as how you filter your information. So how you're going to build an index of the information in your database that is going to be what you use to kind of manipulate information. And what's really cool with the map functions in Couchbase Lite is that you write them in the native language that you're using for your coding. So when I write my map function to go along with something, I write it in Java. I don't write it in something weird. And what you end up doing is building an index, and you do that by when the map function is called, you basically select the things out of your document that you want to present in as the result of your query. So it's actually even kind of cool because in your map function, you're getting to manipulate things the way it's a little more natural to you in Java. And then what you're pushing out for the results, you get to basically pick how it is that you're going to trim that down and what you're going to present to the other part of your code that's going to end up consuming it. And so you have a lot of control over how you do that. So, so yeah, you can get, it does become more complex. I think, there's no way around, if you've got complex data, you're going to deal with complexity. So at some point, this easier approach that I'm doing is going to, for more complicated situations, is going to break down at some point. But for something like, this can take you actually a long way. In fact, one thing that I wrote, I wanted to play with something, so I actually started writing my own kind of chat client. And I did a lot of it, actually. I do use the mapping stuff a little bit, but a lot of it, I'm actually more concerned with just the way I'm pulling stuff in and out of the document. So my main headache at that point is actually just doing the right casting for my variables. So did I over-answer your question, or?
That was probably more than I actually needed.
Okay, I'll live with that. Okay, great. So that was, so that was a lot about Couchbase Lite, and that was really what I wanted to emphasize tonight. Again, I hope that I was able to demonstrate that, at least, and again, this comes from my own experience, that I think working with Couchbase Lite as an on-device solution is really a nice way to go, and I think is worthy of being just your kind of go-to solution for data store on the device. But as I promised, there was a second part to this, which was how, if you start with that you're not going to be left hanging. So here we see all the components that comprise what we call Couchbase Mobile, so the end-to-end solution. So we have the main pieces. So you have Couchbase Lite on one end, so that's your database on device. You have the back end, the server, which is kind of the big iron, enterprise class product that Couchbase makes. And then you have this really nice kind of glue piece that's the sync gateway. So to go into the kind of details of these, Couchbase Lite, full-featured embedded NoSQL database. Portable, you can see a list, hopefully I don't know if that's too low for people, but runs on quite a few platforms. Of course, I wouldn't want to get up and talk to you if it wouldn't run on iOS as well as Android, because I'm not that much of an Android bigot. I probably shouldn't say that. So anyway, to get back on track. So cross-platform support, and actually built for native from the ground up. And at the end, I'll point out the guy who's here who's largely responsible for driving that. Relatively small footprint, and actually you can do full database encryption for people who are concerned about security. Sync Gateway is this really cool piece, and I wish I actually had more time. Encourage people to come back when I have a chance to talk about Sync Gateway, because Sync Gateway actually provides a lot of really cool capabilities that kind of go beyond what we can talk about here. For our purposes tonight, you can think of it as the synchronization layer that presents kind of the web presence that allows you to synchronize your on-device database with your back-end database.
Can I ask a question,
Mm-hmm.
Is there anything in Android that supports that sync functionality of, here's a piece of my device data that really is part of your larger back-end set? Is there something that will help you with a sync function?
I'm not really aware of anything. Google, of course, does some of the tries to do some application data backup in the cloud for you now, but that's not. I mean, that's nowhere near what you're talking about. So I have seen other, there are other libraries out there that try to do pieces of this. I haven't seen anything that comes close to really putting together the full.
I suppose what you have to do in vanilla Android is just throw it all at the server and let the server figure it out if there's multiple streams.
Exactly, and this is taking care of, yeah, so we'll dive into it a little bit more, that what this is really taking care of for you. So there is an underlying REST API, and if you've dealt with REST services on mobile, I think you would agree that they're kind of a headache to deal with, especially if you have to worry about network connectivity, these kinds of things. And so actually all of this stuff can happen is done very nicely for you kind of behind the scenes in the combination of Couchbase Lite and Sync Gateway.
So just on that topic, how were you saying that the Lite syncs with the gateway or with the server if you're not using REST?
So what happens is as far as your application is concerned, you don't deal with any REST stuff. There's REST stuff happening under the hood. So you set up the replication, push and pull replications typically to Sync Gateway. And that's a pretty straightforward thing to do in code. And then it more or less happens in the background for you. I mean, literally, there's actually a separate replication thread and things like this that go on that do that, and we'll handle all the things like, you're being offline and connecting, and we can get into the details like I alluded to some about, what happens if you made a change and somebody somewhere else has changed the same thing. So when you end up with conflicts and how that's dealt with and stuff, and again, kind of beyond the scope of what I wanted to cover tonight, but that's all in there. And then finally, the back end being Couchbase Server, and again, sorry.
Okay, coming back to the gateway again. Okay, so on the mobile device, there's a embedded database, and it goes through the gateway, and there's it
can go to the gateway. So this is something that I want to be really, really clear about, is that you do not have to use anything but Couchbase Lite solely on the device. All the things like Sync Gateway and stuff provide, these extra capabilities that a lot of times for a sophisticated application you'll want to use, but you can just use Couchbase sitting by itself.
Okay, good point.
So,
good point. So yes, you have a database on, you have an embedded database on the mobile device itself, and maybe for some applications, maybe that's enough, having that little embedded database on a mobile device itself. But if say you have your embedded database on a mobile device, and you need to sync up with the main server, like, I don't know, maybe you're playing a multiplayer game, and you're harvesting resources, and you need to have everybody else in your clan be able to see the same thing, see your progress. You have to be able to do the synchronization with that main server itself, and that's actually with the synchronization gateway. Now, with synchronization gateway, is it a direct connection from the mobile device's embedded database to the main server, or is there like some extra steps in there too?
So the Sync Gateway is really can kind of stand alone. So I'm not sure I quite got what the key part of your.
Okay, well, what I'm asking is that, are there like other extra mini databases along the way before you get to the.
Oh, I see. Yeah. No. So essentially, you have your on-device database. Sync Gateway is actually a stateless system, so it's not. I don't really think of it as a database. It's really the synchronization layer. It provides some caching capabilities in effect and things like this, but that's not, you don't think of that as persistent storage, and then you connect to the server, and those are the three pieces you need. Does that answer your question?
Okay, yeah.
Yeah, so in terms of setup, you're not setting up anything besides those three pieces.
The synchronization is not real time, right? I mean, it happens at some point. So just the gaming example that was mentioned, if something changes locally, there is no guarantee that within so many seconds it appears that someone else that is syncing to the same server database, right?
So of course you can't guarantee, I mean that's part of the notion, but
eventual consistency.
Yeah, eventual consistency.
But I mean, like there is like Firebase, which is real time,
real time if you're connected.
Which is real time. If something changes, everyone kind of gets it at the same time. But this is not the same, right?
So it's actually, it kind of is the same. If you want to compare it to Firebase, I think that they are actually basically equivalent because, with Firebase, you have the same issue, right? That you need to be connected and you're doing REST calls to talk to the database back there. So it's not going to get the update unless you're connected. And basically with Sync Gateway, you can, the replication happens. I don't want to get into direct comparison and give you, misinformation. But I think my guess is, I don't know, Wayne, do you want to get in on, well, just how quickly the synchronization happens, not specifically comparing to.
Relatively real time. But as comparison, for example, to preference synchronization that Google offers, which really is not real time. It could be an hour. I mean, they delay it until the right time so that they can aggregate and improve the battery and other performance.
There's actually different configurations for it. So you can have streaming synchronization, which would be real-time synchronization, and then there's what we call one-shot, which it just synchronizes once and stops. You combine that thing with things like timers, push notifications, other application startup life cycles, events, and so you can combine those synchronizations to move data through the system at the rates that you need. And in real applications, actually, data typically moves through the application at different rates. So some data moves fast, some data moves slow. You can imagine moving logs at a slow rate and chat at a fast rate. So you really need that tunability when you get to a more sophisticated application. We provide that in real time.
So just to recap for the recording here, that the question was sort of about whether the synchronization can happen in real time, and the answer is that it happens in a time frame that is effectively real time for a lot of applications, like a chat application or the gaming example that was brought up. For a lot of situations, that would be easily fast enough to handle what you're talking about, I think. I think he was, and then you're next.
So you mentioned that the communication between Couchbase Lite and Sync server?
Sync Gateway, we call it.
Sync Gateway. It's automatic, assume, right?
Right.
So you just play with the local database and then eventually it just gets there. Now, is the communication secure? Meaning, do I have to install a certificate on the server? Is this handled automatically between the components? I mean, how do I secure the communication between the device and the Sync Gateway?
So yeah, you do have. So the question was about how you secure the communications between the device and the Sync Gateway, and so it actually, yeah, you can do it encrypted. It's basically TLS. So as far as the certificate handling, I'm not sure. I would assume I don't know actually what I would hope that.
I'll need the question repeated.
So the question was essentially, so yes, we have secure communications, but how do you handle the because it's using public-private key, typically on TLS SSL setup. How are the certificates handled for that?
Okay, so we support the certificate authorities that register on the phone itself. We also allow you to register your own custom certificates or product certificates in the database itself. So we have APIs for you to register, say, self-signed certificates that you want to package with your application. You can do that too. So we will honor the certificate authorities as packaged with device manufacturers, and honor their certificate stores. I don't know how much you know about that, but you can also add security certificates in different platforms in different ways. And then you can also, inside your application, add them inside the database.
Okay. So the idea then is, let's say if I use a hosting service, right, and I place a certificate on Couchbase instance server, I would assume that then the server keys is responsible for basically deploying the certificate to Sync Manager so that eventually secures the communication with the device?
Yeah, the typical deployment of Sync Gateway is typically behind other Web 3 technologies like a load balancer. So the same way that you would manage certificates in other web technologies is the same way you manage them with Sync.
Okay.
That's server side technology.
So a very short recap, the question was about managing certificates for the securing the communication. Essentially the answer is that we honor the on-device certificate authorities that typically come as a package with something like Android, but you can also add your own certificate authority and such if you want.
And that's client side, and then server side you manage it as you normally would a website certificate.
Yeah, and you manage the server side as you would normally manage your typical certificate setup. You got a question?
I guess the question is, so if I push a document into the sync, do I just assume that it's in there now, or is there a way for me to like check if it's made it inside, or like an OK or a no kind of thing, or is it just like assume that it's made it there?
That one I'm definitely going to defer to Wayne because I've seen different. So again, the caveat that I've been working for the company for 2.5 months, so forgive me for not knowing all the answers, but.
I'm going to come up close to you, so you don't have to do it.
Yeah, I think we're getting into, actually, now, yeah, we'll finish it.
What was the question?
About how you know that the document update has actually made it to the back end and is persisted.
Yeah, so there's ways to do that. It's a little more complicated than answering you right now. You can use our sequence counters for that. It's doable today, not super simple, but there are cases where you want to, say, purge your local database once it's been replicated to the cloud to free up space or for other reasons. And you can do it in the future. We're going to make that a little bit easier for you, but today it's a little more complicated. Right? You have to write some code.
Okay, thanks.
Okay.
That's great.
On a related topic, is having a JSON format really helpful when you're storing a lot of data on the device? Isn't there an inherent overhead in using JSON?
Like storage capacity or something like this. I don't know the exact number as compared to what, like a table and.
Okay, let me answer that question.
Okay.
Okay. One of the things that I think that we should emphasize more, one of the amazing abilities with document storage database, which is that a lot of data out there is non-tabular to begin with. And when something is non-tabular, the ideal data format for that is JSON. Non-tabular data, that's a data tree. Well, what's JSON? Well, that's a data tree. Okay, so I mean, it fits that circumstance, just like that. So, notion of having data being transported as like whole data trees at a time, it's so much more efficient than reducing everything to tables. Database theory itself, most of database theory is taking data trees and entering them in tables. and converting from tables back to data trees. It's like, why do you want to do that? Like convert back, convert back. It is such a pain. So this is actually things like Couchbase, and I myself use MongoDB, but I like Couchbase too. These types of solutions, I think this is actually on the right track in terms of creating an amazing new niche in an area of databases.
So let me restate my question. Are the tags which are associated with every field of the data, are those also stored with every document that you make, with every record, so for that matter?
Are you talking about indexes? Or are you talking about the
actual, well, I guess I call it tag.
So like key value.
So many times the markup is not, we don't necessarily store like a JSON string blob down in the database. That's a representation of the data itself. We may store it in an optimized, we actually do store it in an optimized format in Couchbase Lite. Couchbase Server, I'm not going to speak to that. But, so you can't think that we're just taking the raw JSON string and just sticking it in your file system. It's not. There's a lot of optimizations around the management of JSON. It's really more, very passionate answer there, or interjection. There's a lot more to it than space, right? Space, generally they're going to be very similar, but the reason I asked you what are you comparing it to is because that matters, right? So, yeah, what do you mean? More than what, right? If you're talking about relational stores, many times it's very similar in size, right? And there's a lot of optimizations that are happening down at in the database itself that, you might not transport it like you might think. I mean, you might not store it in the same way you would transport it. So, I guess that's the short answer before, instead of getting into database theory.
Okay, if say you're storing a data tree directly, doing a write with a data tree, that's actually a less complex operation than taking the data tree and writing out to 3 different tables. So that's what you have is like a data tree itself has hierarchical data. Okay, and in database theory, that hierarchical data will be in like say 3 tables, 4 tables, 5 tables, whatever the case may be. So you may actually be doing 5 different data writes to 5 different tables instead of doing a single data write. It's so much more efficient to actually have a tree there and just say write this.
This is why NoSQL is kind of caught on. It's just a more natural way of managing data, splitting up data into, if you look at actually relational systems, right, you're talking about each row is an array of scalar values generally, right? So you need to, anything that's not a scalar value needs to be split up. So if you need to represent an array, that means you're going to need to have a separate table using some type of join operation to represent that array, right? If you want to map or a complex object, you're going to have to do it in the same way, and then you're going to use columns as your field markers, right? So what they're doing is they're cutting up an object that's naturally formed in JSON or other map type structures and cutting them up to fit into slices of scalar values, right? So it just becomes more natural if you can just store the domain object as a whole. And when you do need to split it up, I mean, if you have a relationship, right, a relationship between shared objects where, okay, I have 2 choices. I can share an object or I can dupe the object, right? Well, typically you would share it, which means you would separate it out and then reference a pointer to the other object. So that would be like a contacts in an address book or something like that. You wouldn't put all your contacts in a single address book document. It just wouldn't fit, right? So.
Yeah, I think I'm interested for the Think gateway. So originally, say we design a mobile app. Sometimes we call a REST service. As REST service, we have the backend service can connect to the database, right? If you allow your database to sync for the local data automatically, so that means we don't need to use REST service for backend stuff. I just open up my app. My app will have the local database will sync for me. Besides.
Right, exactly. So basically the example given was about having to have built a REST service to handle doing the REST service yourself. So I mean that's one of the cool things is you don't never have to touch a piece of networking code at all. It just kind of, you deal with a local database and set up your synchronization if you want it to something, to get it off device. And it handles all of that complexity for you.
But the second thing is, since every device have a limited storage, the system space, like 1 gigabyte or maybe 100 gigabyte, whatever. So, but my backend service is huge database actually. So how you handle that situation? Say different users have different devices have very limited space. So what's the strategy on how to synchronize?
So kind of the question is, typical backend system will have potentially enormous amounts of data, much more than you'd want to have specifically on the device. So how do you handle that? And so yeah, what's typically going to be the case is that only some subset of that information is relevant for that device. And there's ways to set up. There's specifically something called channels with Sync Gateway that makes it really easy for you to basically split up your data and sorry, I'm stumbling over this. A channel, you can think of a channel as being basically a way to split up so that you can subscribe to the data that's relevant to your particular interest.
It's like a WebSocket, right? I'm not sure how is the
a channel is more sophisticated than that because a channel you can actually build logic and sync gateway that controls what information goes out based on things like roles, authorization, authentication, what's actually in the document. So you can do a whole bunch of things that are much, and that's so if you think of it in terms of layers of abstraction, you're at a level of control that's way above a WebSocket, and much more, it gives you a ton of flexibility in what information will get pulled down to the application.
So about the synchronize, so how we can control the frequency? I'm not sure how, maybe something is always on the back end running, so waiting for synchronize. In that situation, we run a battery very quickly, right? So once you're energy efficient, so how can the synchronize and more details right now?
So yeah, asking about the efficiency of something that's trying to do the synchronization automatically for you, which is always, of course, a concern in mobile. So I think there are more sophisticated options, but one thing is that you can set up, you can do what they call a one-shot replication. So you can actually control exactly when you're going to replicate, fire off a replication if you want, or you can set it up to kind of automatically just be doing it in the background all the time. And I think there's more sophisticated control than that. But
so replication strategies, which is what you're talking about, are fully configurable. So you can go from, we have two types of core replicators. There's a push replicator and a pull replicator. You can have 0 or more of either one of those in your application. Now, when a replication runs, there are two ways that you can run it. You can run it one shot, which means when you start it, it's going to connect to the backend server, catch up, so it's going to trade data depending on if it's a push, then it's only going to push data up. If it's a puller, it's going to pull data down. It will catch the systems up, and it will never run again, ever again. So you create it, you connect it to the backend, well, you connect it to the database, and it manages it for you, and then you start it. And then it will run, and that's it. If you set a flag called continuous, continuous instructs the replicator to stay connected to the backend server. And we'll try to negotiate a WebSocket connection. If it's able to, then we'll use WebSockets. If it can't, we'll back down and go to long pole. But it will continue to run in the background until you call stop. You can use those two types of mechanisms, and there's more than that. There's things called filters that allow you to replicate only parts of your data with each replicator, which means you can have to move data at different rates. Like you might want to move large objects like images and videos only when you're connected to a Wi-Fi network. And when you're out on your wireless, your metered wireless networks, only send smaller updates or whatever, right? If the battery's low or if you're plugged in or many other things that you might take into consideration on when you're an application developer being a good steward for the user's battery, you can monitor all of that and change your policies accordingly. So that's replication strategy. That's the rate and when and how much and how fast things move. That's your replication strategy. As far as filtering, Hod touched on the fact that Sync Gateway has filter concepts are tied to the security policies. So Sync Gateway has security policy configuration that you set up as a developer. It maps to users or roles, and you can control read access down to the document level, just like a row in a relational system, and write permissions down to the field level, which is like a column in a relational system.
So actually, I was we can keep going with questions for is it okay if I just kind of finish things out and then we can keep going with the, so I'm just going to flip through this really quick. So this gives you kind of a visual idea of those 3 tiers that we talked about. Database on device, Sync Gateway being kind of on the edge for your cloud, and then your server behind that. I'm actually just going to skip over. I think we've actually heard from questions, a lot of use cases. I did want to get to this. This is actually a cool example. So Ryanair, if people aren't familiar, is one of the biggest airlines in Europe. They were having a problem in that their mobile app, using their mobile app, it was taking people like 5 minutes to make a reservation. They decided, and they were getting really poor ratings. Obviously, this is something that's core to their business. It's affecting their business. They came, and after studying how to work and making the decision to work with Couchbase, that I think took around a month, they actually ended up implementing it in something like about an order of a week. It didn't take large architectural changes and stuff, and they were able to improve their performance enormously. And to give you an idea of that, we have this nifty video of the old version with the little spinny weight thing going, and their new version. And you can see, obviously, somebody who knows what they want in a reservation is flying through the second one, but you can see how fast it's moving. So I think this gives you an idea of how much this can affect something that's mission critical for you. And also, I wanted to show you, somebody else's real implementation or real life scenario. So you get the sense of how quickly they're flying. I'm not even sure. Yeah, they're way behind. So this is, that's because you're doing REST calls off device. That's why you're seeing that largely.
That's called wrapping down to a mainframe.
Right, yeah. Driving down to a mainframe. Exactly. So what's new and cool is actually we have the developer preview of version 1.3. I did not talk about any of the things. I'm not going to talk about any of them right now, but there are some nifty new things. This is available now. You can go and download it and start playing with it. So all the stuff that I talked about is available, and some new stuff that's coming up. Developer preview means that we're getting really close to releasing it. I don't know if we actually want to say anything about schedule or not, but keep your eyes open, yeah. So with that, again, I hope the main takeaway is that I think it's easier to use and is really a full, complete solution. I have not seen a solution that I think, there's solutions that have their merits. I think this provides a lot of the really key pieces when you want something that kind of end-to-end, like sort of something like the Ryanair case. And there's all sorts of more things going on there that we've sort of run out of time to talk about. So thanks everybody for coming. That's me. Follow me. I like followers. You can follow Couchbase Dev to get up-to-date information in Couchbase Mobile, both. So Couchbase Dev, if you want to find out more things about, and Couchbase Mobile, if you want to find out about stuff with Couchbase, specifically like the 1.3 release. And that's it.